Hey there, Mr. Weaver here, and this is lesson 4 of our geometry unit, the converse of the Pythagorean theorem. After this lesson, you need to be able to determine if a triangle is a right triangle based on the sides given. You'll know you're successful after this lesson if you can check if triangles are right triangles by using the Pythagorean theorem. Here we're going to check to see if triangles are right triangles using the Pythagorean theorem. So in the last lesson we learned that the Pythagorean theorem only works for right triangles. So the converse of the Pythagorean theorem, which is essentially like almost thinking about it backwards, says if the Pythagorean theorem works, then that triangle has to be a right triangle because it doesn't work for any other triangles. So to do this, you're just going to check to see if a squared plus b squared does actually equal c squared. If it does, then it's a right triangle. When you're doing this, our triangles in question are going to not have that little box symbol to show that it's a right angle, which is why we need to check. Because if that symbol was there, then we would already know that it would be a right triangle. So let's get right to this. Is this a right triangle? We have sides of 7, 24, and 25. So we're just going to check, does a squared plus b squared equal c squared? Remember, a and b are your shorter sides. So 7 is the shortest. I'm going to call that a. 24 is the next shortest. I'm going to call that b. And then our hypotenuse is c. So we're going to check, does a squared plus b squared equal c squared? So is 7 squared plus 24 squared equal to 25 squared? Let's just calculate it out. 49 plus 576, does that equal 625? 625 equals 625. Yes, that's true. So it is a right triangle. Even though it didn't have that little square there, it is a right triangle. So we just checked if a squared plus b squared equals c squared. If it's yes, it's a right triangle. If it's no, then it's not. Now it's your turn. Is the triangle you are given a right triangle? Let's check. You should have said yes, yours was a right triangle as well. If we check to see if 5 squared plus 12 squared equals 13 squared, we get 25 plus 144. Does that equal 169? Yes, 169 equals 169. It is a right triangle. Let's look at another example. A triangle has sides of 12, 12, and 17. Is it a right triangle? So I need to know, does a squared plus b squared equal c squared? Here, a and b are going to be my shorter sides, so 12 and 12 are the two shortest. So do those two squares equal 17 squared? 12 squared is 144, 12 squared is 144. Does that equal 17 squared, which is 289? We get 288 equals 289. Those are super close, but it's not exactly equal, so it is not a right triangle. It needs to be exactly the same. So be super careful. Sometimes they might be real close, but they have to be exactly equal. Otherwise, the Pythagorean theorem doesn't work, and it's not a right triangle. Pause the video again. Test out yours. Could a triangle having sides of 8, 15, and 17 be a right triangle? You should have found that yes, that is also a right triangle. So a squared plus b squared equals c squared. 8 squared plus 15 squared is equal to 17 squared. Let's check. 64 plus 225 is 289. You get the same thing, 289 equals 289. So, yes, it was a right triangle. Again, had to be exactly equal. In this lesson, we learned that the converse of the Pythagorean theorem states that if the Pythagorean theorem works, then that triangle is a right triangle. Because, if we remember, the Pythagorean theorem only works for right triangles. So, if we want to know if a triangle is a right triangle, and we know all the sides, just check to see if the Pythagorean theorem is true. So does a squared plus b squared equal c squared? A and b have to be the shorter sides, the legs. C is the hypotenuse, your longest side. As long as you put them there, if a squared plus b squared is exactly c squared, then it is a right triangle. If you don't get the exact amount, it's not a right triangle. Even if it's super close, if it's not exact, it's not a right triangle. After this lesson, do you now know how to check if triangles are right triangles by using the Pythagorean theorem? If you're not sure about this, go back and look at some of the examples to deepen your understanding of that converse of the Pythagorean theorem. If you're having trouble with the Pythagorean theorem in general, you should probably go back to watch lesson 3. And that's the end of lesson 4 on the converse of the Pythagorean theorem.